Welcome to A-Level Physics, Cambridge A-Level. This one summarizes for you what we are going to learn about scalars and vectors. We are going to study about vector addition, subtraction of vector, finding components of a vector. Resources you can find in under this heading, Physics AS. This one is for the notes and my video. Or you can go under my name, Hin. You can find it under YouTube channel. You want past year paper, the older one will be here before 2019, I think. 2019, sorry. Past year paper will be here. The model answer. Paper 3, also before 2019, will be there. If you want to know how the examiner mark and model answer. As I say, important syllabus will tell you what you want to cover, how much you need to know, and then you try the past year paper so that you know you've studied enough. Because you want to study more, it's your choice. Right? This one is for general knowledge if you have the time. So scalars and vectors. 1. Understand the difference between scalar and vector quantities and give example of scalar and vector quantities include in the syllabus. Add and subtract coplanar vectors. Coplanar means on the surface, 2 dimension, not 3 dimension, but on the surface, 2 dimension. Represent a vector as 2 perpendicular components. Right. Let us start. What is a scalar and what is a vector? A scalar quantity has magnitude only. It doesn't have a direction. It's just a number. Example, mass, time. A vector quantity has both magnitude and direction. It has 2 things, magnitude and direction. Example, velocity and acceleration. State which of the following quantities are scalars and which are vectors. Right? Circle the scalars. Have a go. Right? Electric charge is a scalar. Pressure is a scalar. Potential difference is a scalar. Length is a scalar. Kinetic energy is a scalar. Temperature is a scalar. Volume is a scalar. The others are vectors. Vector is a directed line segment. It has a particular length and a particular angle. How to represent a vector? These are some of the ways of presenting. Textbook tend to use this one called boldface. Right? Right? We just draw a vector with a direction A, B. So you don't want to put it as this way. You can put it as AB. Right? As I said, textbook will use boldface, but for you, you need to recognize it. What is the vector? And solve the problem using vector triangle or component if it's a vector, which we'll be learning today. Right? It has a magnitude, it has a direction. So how do we specify the direction? Example, this one, velocity, 50 meters per second, 60 degrees. So velocity is 50 meters, south, 60 degrees west. This is south, 60 degrees west. That is your west. This is your east. Or sometimes you want to use bearing. bearing will always refer to the north. This is the north. So this is 180 plus 60 is 240. So we can say object is moving at 50 meters per second at a bearing of 240 degrees. Right? 180 plus 60, 240. Or we can say that 60 degrees west of south. This is your south. West of south is here. Okay? Different textbook will use differently. There's your south, there's your north, there's your west, there's your east. Equal vectors. Two vectors are equal when they have the same length. And parallel. That means they must be same length, same direction. Right? You can use graph paper to draw. Right? You can write as A equals to B. So same length, same direction. That is called the head, arrowhead. That's the arrow tail. Negative of a vector. Right? Negative vector minus A is a vector of same magnitude but opposite direction. If that's our A, and minus A, right? Just opposite direction, same length. Vector equation. The addition of two vectors is a single vector called the resultant vector. The resultant vector R has the same effect as the two vectors. Addition of vectors A and B, right? We write as equation A plus B or B plus A. R is called the resultant vector. We can add vectors in any order. I can start with A first, then draw B. I cut with B first, draw A. Right? Remember, this is a vector equation telling the order of addition. So you cannot just simply put numbers inside, representing A and numbers representing B and add them out or subtract, unless they are on the same straight line. Right? Because vector has a direction. You have to show the direction and draw the diagram before you can solve the resultant. Okay, let's try the example using triangle rule. This is your A, 30 degrees to horizontal. That's the tail, that's the head. That's your resultant, A plus B. So we draw a line to represent horizontal. Then this one tells us we draw A first. Right? If you use graph paper or scale drawing, right? Graph paper or scale drawing is the same. You can draw that exactly the same length or a bigger one if you want to. Right? There's a scale drawing already if you are using the longer one. Right? When you sketch, you have to draw roughly the same length, roughly the same angle. No need to measure if it's a sketch. As a tail, as A. So you start drawing from A, from the tail to the head. So at the head here, you place this one there. Right? But remember, this is 30 degrees. There's a 30 degrees there. So draw vector A with its magnitude and direction. Vector A with its magnitude and direction. Right? If it's scale drawing. If it's a sketch, you don't need to measure the length at all. At the head of A, draw your B. That's how you draw your B. So there's your B. So that's where you start your drawing, and that's where you end your drawing. So where you start and where you stop, you just join them up. That's the resultant. Right? So that's your R. Now you can use parallelogram method. Just now we use triangle method. Parallelogram has two opposite sides, parallel and equal. Right? If parallel equal, and that is your diagonal. Right? So suppose we have two vectors, one is A, one is B. That is the magnitude. Magnitude. That start the two vectors from the same point. We can choose a point on the graph paper that you want to scale drawing. Draw your A. Sketch, you can sketch roughly. Doesn't have to be measured, doesn't have to need a graph paper. And at this point, the same point, draw B. Then we form a close, complete the parallelogram. Yes, these two are parallel. So this is also A, this is also B. And then draw the diagonal. That is the resultant. Right? As I said, commutative, you can either, as your R, is from adding A, B, or adding B to A. Okay, remember, direction must be drawn, then we can calculate. What are we doing? We are replacing two vectors with one vector. This single vector, called the resultant, has the same effect as the two vectors. That's all. These two vectors represent your resultant. It has both of them have the same effect. But it's wrong to draw that way and then join it here. Like that. It's wrong. Right? Because this one, basically, that is your body here. The two, if you think of forces, this is the two forces acting on the body. The body will be going this way, not going that way. Right? All the vectors and the resultant must start from the same point. It's for parallelogram rule. Right? Remember that. Right? Cargo ship is pulled by the tugboat. So either you have these two forces acting on it, it's moving this way, or we use that resultant force pulling it that way. Right? Or we can use triangle of forces to show the resultant. Subtraction of vector. That's given A, that's your B. S is A minus B. So the first thing, of course, we draw A. Okay? And we have to write the equation. What the subtraction means? It means that A plus minus B. Add to vector A the negative vector B. So that's your vector A. Right? Same length, probably same length. A. Right? We can use triangle rule or parallelogram rule. Doesn't matter. Yeah, it's a purely choice. Parallelogram rule, we have to start from the same point here. So if it's plus B, then that is your plus B. So plus B. So minus B will be opposite direction. Right? So that's plus B, that's minus B. We want this one, not this one. Right? So that's where we start. Draw that. That's the head. And we have the tail there. That's where we end. Right? On the second vector. So we join that up, get the resultant. So starting from point the tail, that's the starting point, the tail. Join the starting point to the end point, where we start to draw. And we end the point there. So that's the resultant. So that's your S. Let's try some question to reinforce what we have learned. Check that you understand what is happening. What is a scalar? What is a vector? This is Cambridge 2004 June. Have a go. Scalar quantity has magnitude only. Vector quantity has both magnitude and direction. Speed of a car changes from 50 km per hour to 80 km per hour So which is the right answer? Correct. B. Right? We are adding scalar. We are subtracting scalar if you like. Right? The speed increases by 30. 80 minus 50 is 30. This is also a partial question. Which of the following pairs contain one vector and one scalar? Right? These are two vectors. This vector is scalar. This vector, scalar, scalar. So answer is B. Have a go at this one. Diagram, this is a partial question. Shows arrows representing two vector quantities. Which diagram shows the resultant of these two vectors? So they are using parallelogram rule. Right? We must start the two at the same point. Two at the same point there. Okay. If you use triangle rule, you draw this one first, then draw that one, and this is the wrong direction. Right? So this one doesn't make sense. Right? Be joining this way. This one is also wrong. So the only answer is this one. Right? That one is that one there. That one is that one there. Complete the parallelogram, there's a resultant. Answer is donkey. Or I can draw it out on the diagram. Right? There's a vector plus this vector. There's a resultant. So that's the answer. Donkey. B. Forces of 6 Newton and 4 Newton and 6 Newton act at a point. Which one of the following could not be the magnitude of the resultant? It didn't give you the direction. So it's up to you to choose all the direction, all the possible direction. Right? So the largest will be when they are in the same direction. 6 and 4 in the same direction. So it will give, we just add them up because they are in the same direction. 10 Newton. Right? The smallest will be when they are in opposite direction. Right? So opposite direction is subtract. So the resultant is 2. That one is 4. Is 6. That's 2. So the rest, right, can obtain this one. You just basically turn this one around, that's all. Right? Or we can start with 6. And there's your 4. Right? We just change this angle, that's all. Where we make this one parallel, same direction. And this is what we get. Or where we change the angle, right? We get less than 10. The resultant is less than 10. Depending on this angle. Right? If we push it back there, and this is the one that we get. The answer is A. Cannot get 1. Okay, so this one do the same thing. Okay. 6 plus 4, we get 2. And the other length that we can get will be by changing the angle, this angle between 4 and 6. Okay, what's the resultant force? 3 coplanar forces of magnitude 2 Newton, 19 Newton, and 5 Newton act on the body at P. That's your P here. In the direction shown in the diagram below. What is the resultant force? Right? Go with this one first. 19 is greater than 2, so it should be 17 here. And 5 is still one direction. Only one vector there. So that is a 17. 19 minus 2, 17. Complete the rectangle. So that's the resultant R. So it's 17 plus 5, 17 square plus 5 square. Pythagoras theorem. Use a calculator. So usually your answer is only two significant figure. Sometimes they will specifically ask for 3. The answer is donkey. Let's try another one. 2 possible displacement of an object are represented by vectors P and Q. There's a vector P, a vector Q. Which vector best represent the resultant P minus Q? So that's your P. You can use triangle of forces or parallelogram rule. P minus Q is just P plus minus Q. Right? So minus Q is here. So we can use parallelogram rule, or we can transfer this one to here using triangle rule. And that's the answer. Donkey. Right? As I said, we can add any order as long as you must follow the direction. 3 wires each exert horizontal force on a vertical pole as shown. That's a vertical pole. There's a forces, 3 forces. Which vector diagram shows the resultant force are acting on the pole? Okay, yeah, we can try out. This is correct. This is correct. This direction is wrong already. That one is correct. That one is correct. That one is correct. So that's the answer. Oh, this one is wrong. Direction. No need to check anymore. This is correct. That one is correct. This one. That one. But it should be going. This one should be going down that way. Right? Coming down that way, not going up. So you can draw yourself. Right? As a resultant, the answer is your B. In this case, all the arrow is in one direction. In this case, is clockwise. So R is not a resultant. It's the force required for equilibrium. Two forces of magnitude 5 and 7 Newton act on a body B. That's your point there. If you like, the body is represented by a point. The angle between the direction along which the forces, so this angle is 40 degrees. Determine the magnitude of the resultant force on the body by completing the diagram using a suitable scale or calculation. The exam, you're allowed to use scale drawing if you prefer that, or you can calculate. So we complete, can draw out now. Remember, we vector addition, we have to draw the diagram. Cannot simply add 5 and 4. Right? Even though our vector equation will say we add this vector plus a vector. That's just a vector equation, but we have to draw it out the direction and find a resultant. Right? So these two are parallel. It's 40. 180 minus 40 is 140 here. So we use our formula. I'm going to find R7 square plus 5 square minus 2 times these two together, multiply together, cos 140, cosine rule, and square root that, 11.3. We can round off to 11. And looking at this triangle, 5, you want to find this angle, the sine theta, it has a direction. So with magnitude, then we have a direction. So this the angle sine theta over 5 is sine 140 sine root divided by R. R we already calculated that. So theta is just that 17 degrees. Right? So this one you can write up to 11 because most of it are only two significant figures. go to components of a vector. Right? Both previously, you want to find the resultant of two vectors or more than two vectors, you can use the same idea. Component is another way of finding the resultant vector. Both are ways to find the resultant vector. Previously, we learned to find the resultant vector from two vectors, A and B. Right? We draw, complete the rectangle or parallelogram, then find our F and find our angle. Right? That's what we are doing. This topic, we are finding the vector. We are given a vector. We want to find the component of this vector. We are finding two vectors, and we call it component. Right? This is your vector given with an angle there, with a direction. So the same thing, we want perpendicular direction. It's easier to work with perpendicular direction. Then complete the rectangle. And this is your the magnitude of F in the y direction or y component is the x component. Right? So instead of thinking of it as one vector, we think of it one vector given, we resolve into two components. Here we are given a vector at a known angle and we want to find two components that are perpendicular to each other. So we just draw we got the x-axis, we draw the y-axis, complete the rectangle, and Fy is the vertical side, Fy. Right? This is also Fy, opposite side of rectangle, Fy. Fx, horizontal side of the rectangle, is Fy. Fx, sorry. Right? This is also Fx, opposite side of rectangle. So Fy we call component of y, F in the y direction, or vertical component. So it's easier to remember, right? F far away from this angle is sine theta. We can call it horizontal component or component of F in the y direction, in the x direction, sorry. So angle is adjacent side, so it's F cos theta. Or you can use the way you have learned before. Right? Sine theta is your Fy over F, and we get the equation. Cos theta is Fx over that. Right? The equation. It's faster if you can remember that one. What are we doing? Instead of thinking of a vector, we replace the vector with its component into perpendicular direction. That's all. That's all we are doing. Okay? The two components have the same effect as this single vector. Inclined plane, right? Which you should know. There's an inclined plane. There's a horizontal. Angle theta. Normal is a line perpendicular to the surface. There is a surface, a plane, inclined plane, perpendicular to the surface. 90 degrees. So you draw a vertical. That one is 90 degrees to a horizontal. So this is also 90. So this must be 90 minus theta. Right? This is a right angle triangle. These two add up 90. So this must be theta. Okay? Memorize it or know how to derive it. A wooden block of weight W resting on the inclined plane. That's a wooden block. That's an inclined plane. The angle to the horizontal. Right? That's an example of man moving sand up a inclined plane. Right? Plane is inclined to the horizontal at an angle of theta. Right? And draw. Basically, we are interested in motion up or down the plane or perpendicular plane. It won't go down directly this way. That's why we have two perpendicular directions. Horizontal parallel to the plane and perpendicular to the plane. So our component, right, perpendicular to the plane, that's the component of weight perpendicular to the plane. That's your angle theta. This is theta, and that must be above theta. Right? So that's a component parallel to the plane. Component of weight parallel to the plane. This one. Right? Two parallel lines. Drop form. W sine theta. Right? Far away from this angle. Component of weight perpendicular to the plane. This one. Right? So it's this component W cos theta. Right? Have a go. Have a go. What is the horizontal component? Magnitude horizontal component. Right? 5 cos 53, 3 Newton. Component in the vertical direction, 5 sine 53, 4.0 Newton. These are all the sine and cosine rule that you need to remember. You need to know how to use it also for A level. Right? There's the angle given, A and B given. So to find C, so A squared plus B squared minus 2 times A times B cos this angle. Okay. Maybe we'll apply vectors in throughout the syllabus. Example will be conservation of momentum. Body A of 10 Newton. 10 Newton second. Collide with body B. That's a body B. 3 Newton. Newton second. Right? This is initial. This is after collision. After collision, the momentum is A is 7. So you are required to find the momentum of B. Right? So we can draw that. P1, P2. Same. Final momentum must be the same as the initial momentum. The total or the sum of the momentum must be the same. So sum of momentum before collision, sum of momentum after collision. Right? Remember, this is a vector equation. We can put numbers in because they are all horizontal. So this is 10. There's 10. There's 3. And this one is P3, P4. So this is 7. And there's your P4. So we know that is the final direction. So 13 minus 7 is 6 Newton second. Right? We can use polygon rule, like in this case, to find the resultant. You can add any order you want to. Right? A, that's your A, same length. These two must be the same length. Then B, C, that's your C. Then D, that's your D. E, that's your E. So that's your resultant. Okay. So we use polygon rule if it's many vectors. R is the resultant. right? If it form a closed triangle, then that's where we add it up, we get 0. 0 is called a null vector. Just 0, no direction, no magnitude. Okay, let's try some question. Try this one. 5 Newton makes an angle of 60 degrees with the y-axis. What's the horizontal component of 5 Newton force? Right? Far away from this angle, so it must be sine 60. Or if you want, you can use 30 here. 5 cos 30. Then, how about this one? 4 forces act on a point as shown. What's the size of the resultant force? Same thing. This one is larger. This one is smaller. So the resultant must go in the 8 minus 4 is 2 Newton. Right? 2 minus 2 is 0. Answer is B. 4 forces act at a point as shown. What is the size of the resultant force? Right? Same thing. It is what is given. Right? Vertically, this is larger. This is smaller. So the resultant 5 minus 2 is 3. And then 8 minus 4 is 4. In that same direction as this one. Then complete the rectangle. That's the resultant 3, 4, 5. And then that's the angle. Right? 8 minus 4. Vertically, y direction 5 minus 2 is upwards. The resultant is 3 square. Pythagoras theorem, 3 square, 4 square, square root that, 5 Newton. Right? Angle theta, this is a rectangle, so this is a rectangle. So this 3, this must be 3. So 3 over 4, tangent, the theta is 37 degrees. A wooden block of weight 20 Newton is placed in an inclined plane. The plane is inclined at 30 degrees horizontal. What's the component of the weight down the plane? This is the one we want. What's the answer? Right? This 30, this 30. Complete a rectangle. Right? Far away from this angle, this one. So it's 20 sine 30, 10 Newton. Answer A. Okay, it's just a repeat. Okay, I will go at this one. Three coplanar forces of magnitude 20, 40, 50, shown in the diagram below. North is the north, bearing 0 degrees. Which one of the following is the approximate bearing of the force required to maintain equilibrium? B is just that point. Okay. Then before this 40, there's no others, one vertical. So there's a 40 there. And then 50 is greater than 20. So 50 minus 20 is 30 Newton. To complete the rectangle, that's the resultant. That's the angle theta. Resultant. We don't want that resultant. We want equilibrium. Force required for equilibrium. So it's exactly the same as the resultant magnitude, but opposite direction. So that this point will not move. So solution, you have to find this angle, right? This is 40. This is opposite side of the rectangle, so this is also 30. So 37 degrees. So bearing, okay, we are interested in this direction. So this one is theta. Vertically opposite is also theta of 37. So it's 180 of 37 donkey. Okay, that's the end of our lecture. Thank you.